Right now, as you are watching this, one of the most important circulation systems on the entire planet is doing something it has not done in over 1,000 years. Scientists monitoring the Atlantic Ocean have confirmed that the Atlantic Meridional overturning circulation, the vast system of currents that includes the Gulf Stream, has weakened to its lowest measured strength in the modern instrumental record. New data released this year shows the slowdown accelerating faster than the models predicted. Ocean buoys stationed across the North Atlantic recorded a sustained drop in northward heat transport. Salinity readings near Greenland have dropped to levels not seen since monitoring began, and European climate agencies have quietly upgraded this from a long-term concern to an active area of emergency modeling. This is not normal news cycle noise. Something significant is happening inside one of the engines that regulates weather for over 1 billion people. And today, we are going to break down exactly what is going on, what scientists warned about years ago, and whether the thing they feared most is now actually beginning. No guessing, no dramatizing, just the facts, the science, and the real stakes. Drop a comment right now. Have you noticed unusual weather where you live this year? Colder winters, wetter summers, storms that do not behave the way they used to? Tell me where you are and what you have felt change. Thousands of you have been sending me stories about strange seasons for months now, and I always love reading them. If you want to be the first to know every time something major happens with this story, subscribe to the channel right now. It is completely free. A thumbs up also helps enormously. Let us go for 5,000 likes on this one so the algorithm actually shows it to people who need to see it. Thank you. Now, let us get into it. For decades, climate scientists have warned about one specific nightmare scenario buried inside their models. Not warming, not sea level rise alone, something stranger and in some ways more frightening. A collapse, or a severe weakening, of the Atlantic Meridional overturning circulation, commonly shortened to AMOC. This is the ocean's conveyor belt. Warm, salty water flows north along the surface from the tropics, releases its heat into the atmosphere as it travels, which is a major reason why Western Europe stays far warmer than its latitude should allow, then cools, becomes denser, sinks near Greenland and the Norwegian Sea, and travels back south along the ocean floor. That sinking motion is the engine. It is what pulls the whole system forward. Without it, the belt stalls. For years, this was framed as a distant risk, something that might happen by the end of the century if warming continued unchecked. That framing has changed. In February of this year, researchers using data from the Rapid Array, a chain of scientific instruments stretched across the Atlantic at 26 degrees north that has been continuously measuring ocean transport since 2004, published findings showing that AMOC strength has declined by approximately 15% since the middle of the 20th century, with the steepest portion of that decline occurring in just the last 2 decades. Let me explain why that number matters more than it sounds like it should. A 15% decline in a system that regulates heat distribution for the entire North Atlantic basin is not a rounding error. It is the difference between a stable climate system and one that is measurably losing the mechanism that keeps it stable. Here is where the story gets more alarming. Dr. Stefan Rahmstorf, one of the most cited oceanographers studying this system, along with a team publishing in Nature Climate Change, used sea surface temperature patterns as a proxy for circulation strength, going back further than direct measurements allow. Their reconstruction places current AMOC strength at its weakest point in over 1,000 years, weaker than during the Little Ice Age, weaker than any period captured in the sediment and temperature records scientists have been able to reconstruct. The system is not simply fluctuating within its normal range. It is operating outside of it. A separate study, led by Peter and Suzanne Ditlevsen, statisticians at the University of Copenhagen, went further and did something that made headlines around the world. Using statistical early warning signals, the kind of mathematical techniques used to detect when a complex system is approaching a tipping point, they analyzed decades of sea surface temperature data in the AMOC's subpolar gyre. Their conclusion placed a most likely collapse window sometime between 2025 and 2095, with a central estimate landing around the middle of this century. Other research groups pushed back on the exact timing, arguing the uncertainty range is too wide to pin down a specific decade. But almost none of them disputed the underlying direction. The system is weakening. The only real scientific disagreement left is about how fast. Now let us understand what a collapse or severe weakening would actually mean, because a lot of people hear ocean current and assume this is a slow background process that will not touch their lives. It is the opposite. The Intergovernmental Panel on Climate Change has stated with high confidence that an AMOC collapse would trigger abrupt, and in human timescale terms, largely irreversible changes. Western Europe would face a sharp regional cooling even as the rest of the planet continues warming, because of the heat that currently gets carried north and released into the atmosphere over places like the United Kingdom, France, and Scandinavia would simply stop arriving. Some models suggest parts of northern Europe could cool by several degrees Celsius within a matter of decades, a shockingly fast shift by climate standards. At the same time, sea levels along the eastern seaboard of the United States would rise faster than the global average, because the current currently helps hold water away from the coast through the physics of ocean dynamics, and a weaker current means that water piles up closer to shore. The West African monsoon and the Indian monsoon, systems that hundreds of millions of people depend on for agriculture, would shift in ways researchers describe as severe and difficult to predict with precision. This is not a hypothetical bad year. This is a reorganization of regional weather patterns that took thousands of years to stabilize, potentially unwinding within the span of a human lifetime. This has happened before, and the historical record is genuinely unsettling. Around 12,800 years ago, at the end of the last ice age, the planet was warming out of glacial conditions in a fairly steady way. Then, in a geological instant, everything reversed. Ice cores from Greenland show that a period now called the Younger Dryas began, in which the northern hemisphere plunged back into near glacial cold within as little as a decade. Some records suggest possibly faster. The leading explanation among paleoclimatologists is that a massive pulse of glacial meltwater, released as the Laurentide ice sheet over North America broke apart, flooded into the North Atlantic. The freshwater diluted the salty surface water that normally sinks to drive the AMOC. Freshwater is less dense than salty water. It does not sink the same way. The sinking engine stalled, the conveyor belt stopped, and an already warming planet was thrown backward into over 1,000 years of bitter cold before the system eventually restarted. Read that back one more time. A stalled AMOC pushed the northern hemisphere back into ice age conditions within a decade and kept it there for over a millennium. That is not ancient trivia. That is the same physical mechanism scientists are watching weaken again right now, driven this time not by a collapsing ice sheet, but by accelerated melting of the Greenland ice sheet and increased freshwater runoff from a warming Arctic, doing precisely what glacial meltwater did 12,000 years ago, freshening the surface water, interfering with the sinking, slowing the belt. The contrast between then and now is not about the mechanism. It is about what we can see coming. 12,000 years ago, there were no instruments, no satellites, no ocean buoys, no scientists tracking salinity in real time. The system stalled, and human populations experienced the consequences with zero warning and zero ability to prepare. Today, we have the rapid array continuously measuring transport at 26 degrees north. We have Argo floats, thousands of autonomous ocean probes drifting through every major basin, constantly reporting temperature and salinity data back to research centers. We have satellite altimetry tracking sea surface height with millimeter precision, because a weakening AMOC leaves a distinct fingerprint, a patch of unusually cold water south of Greenland that researchers have nicknamed the cold blob, sitting in stark contrast to a warming planet around it, visible clearly in satellite temperature maps. This is the one advantage we have that the world 12,000 years ago did not. We are not walking into this blind. The question is whether that early warning translates into meaningful action. The same way earthquake early warning only saves lives if people actually respond to the alert instead of ignoring it. So is the AMOC definitely going to collapse? Let us be honest about the uncertainty here, because overstating this helps nobody. The scientific community is not unified on exact timing. Some oceanographers argue that current observational records, only spanning roughly 2 decades of direct high-precision measurement, are too short to fully separate long-term decline from natural multi-decadal variability. The AMOC does fluctuate on its own on cycles lasting years to decades, influenced by factors like the North Atlantic oscillation, and disentangling natural noise from a genuine forced trend is one of the hardest problems in physical oceanography. A 2024 assessment published by a broad panel of AMOC researchers stated explicitly that while a full collapse this century is considered unlikely under most emission scenarios, it cannot be ruled out, and a substantial weakening of the kind already being observed is already considered extremely likely to continue. In other words, the most extreme headline version of this story, an abrupt total shutdown within years, is not the scientific consensus. But a serious, damaging, and increasingly irreversible weakening over the coming decades is already underway and already measurable. That distinction matters. This is not science fiction catastrophism. It is a slow-moving, well-documented trend that is accelerating faster than earlier models expected, watched by an international community of researchers who are increasingly uncomfortable with what the data shows. Let us be direct about the practical message here, because information without action is just anxiety. You cannot personally slow an ocean current, but you can understand what a weakening AMOC means for wherever you live, and that understanding is not nothing. If you live in Western Europe, particularly the United Kingdom, Ireland, France, or Scandinavia, this is the single most important long-term climate risk to track for your region, because the outcome is not simply less warming, it is a genuine possibility of regional cooling layered on top of a warming planet, an outcome most people have never been told to prepare for. If you live along the eastern coast of the United States, understand that accelerated regional sea level rise tied to circulation changes is already being factored into updated flood risk maps in cities from Boston to Miami, and checking your property's current flood zone designation takes about 10 minutes online. If you depend on monsoon-driven agriculture anywhere in West Africa or South Asia, this is now part of the long-range risk conversation among regional climate services, and staying connected to local agricultural extension advisories matters more than it used to. None of this requires panic. It requires the same thing Japan's earthquake preparedness required: sustained attention to a slow-moving, well-understood risk, long before the worst-case version of it arrives. Final thought. The Atlantic Meridional overturning circulation has been running in something close to its current form for roughly the last 12,000 years, since the planet climbed out of the last ice age and settled into the stable climate that allowed human civilization to build cities, agriculture, and everything that followed. It has stalled before. It restarted before. It will very likely find some form of equilibrium again on a timescale measured in centuries, regardless of what we do. What is genuinely at stake is not the ocean's long-term fate. The ocean will be fine. What is at stake is whether the stable climate window that human civilization was built inside of continues to hold during the lifetimes of people alive today, or whether we are watching, in real time, the early stage of the kind of abrupt reorganization that the geological record shows the system is fully capable of producing. 12,000 years ago, nobody saw it coming because nobody could. Today, the instruments are in the water, the data is public, and the scientists who study the system are telling us plainly what the numbers show. The gap between having the warning and acting on the warning is the only part of this story that is still entirely up to us. We will keep tracking this as it develops, every new rapid array reading, every updated Greenland melt estimate, every fresh study on collapse probability. Subscribe so you do not miss updates on any of it, and leave that comment below. Have you noticed the weather shifting where you live? Tell me what you have seen. Because this is not just an ocean current. It is the system quietly keeping the climate you grew up with in place. Understanding that is how we stay motivated to take this seriously. 5,000 likes on this video. Let us go. See you in the next one.